Hi, Brandy. It is a new instrument called SAGE 3 ISS, and it's headed to the station in the next year and a half. It's the fifth in a series of SAGE instruments that date back to 1975 that study the main components of the upper atmosphere: ozone, aerosols, and water vapor. I spoke with the mission operations manager for SAGE 3 to find out more about how its measurements will help us understand climate and how human activities influence it.
Okay, so it's the SAGE 3 on ISS, which stands for the Stratospheric and Aerosol Gas Experiment on the International Space Station. It is a fifth in a series of SAGE instruments, and we will be launching in early 2015. And what the instrument does, it actually tracks the sun and the moon as they rise and set behind the Earth. And as they rise and set, the atmosphere absorbs at certain wavelengths and scatters at certain wavelengths. And what this can tell us from the absorption and scattering is the different gases and aerosols and the amount in the atmosphere.
Why is it important to study this?
Because we study aerosols and ozone, and as most people know, ozone protects us from the sun's radiation. And the radiation is harmful, it gives us burns, it depletes our crops if we get too much. So SAGE 3 monitors this ozone and tells us how much we've lost. And then since 1987, due to the Montreal Protocol, and they regulated these ozones, or CFCs that hurt the ozone, we now at SAGE 3 and ISS will monitor the recovery of the ozone.
So you've been studying this since '75. What have we learned?
We have learned, we've got very accurate measurements of the ozone, so we've been able to trend the amount of ozone that we've lost, and now we will be able to trend the recovery of the ozone itself, along with aerosols and gas vapor.
It may be obvious to folks, but why is this important to us on Earth?
Because it protects, like I said, the radiation from the sun is very harmful to humans and to our planet. And so to be able to monitor the loss or the recovery of the ozone will help us in understanding our climate.
How does it work?
So the way it works is it tracks the sun and the moon as it goes through the atmosphere. As it tracks it, light will go into the instrument, it'll hit a diffraction grating, which will break it up into those wavelengths, which will tell us what gases and aerosols are in the atmosphere. It then hits a CCD, or pretty much a fancy digital camera, and we take a snapshot of that. And we do this continuously as it goes through the atmosphere, so then when we're done with the science event, we actually have a very nice profile of aerosols, ozone, water vapor at a given location. And then we can do this numerous, on ISS, all over different latitudes and different seasons. The instrument was actually built about 10 years ago. We were planning to go to the space station when it was first being developed, but the configuration of the space station changed, and so we went into storage. So about 3 years ago, we pulled it out of storage, did some testing to make sure it's still functioning. It functions perfectly. So now we are slated to go up in 2015 and be up there at least 3 years, and hopefully for the full mission of ISS.